Okay, screen is visible to all of you.
Yes.
So now today we will go for the first practical, that is VHDL code for the half adder and full adder. Okay, so you have to quickly you have to just tell me the processor. Now all of you are familiar with this. How to execute VHDL code in this Xilinx Navigator, Project Navigator. Okay, so what is the first step? This is the what we can say the opening window of that software. Okay, after that, what should I do? Please be fast. We have to execute this actually. Tell me the steps. First, make sure that you are at implementation mode. Okay, then go to file, then new project. Okay, then uh, FDD. Okay, full adder FADD. This name I will give full add. Okay, next, next, finish. Okay. Now this folder appears here. Then what should I do? Right click on this new source. Hmm? Then VHDL module. What name? Full add. Okay. Make sure that you have selected the uh, this VHDL module. Then next we have to choose the inputs and outputs. Okay. Now what are the inputs and outputs for this full adder? What are the inputs and outputs for full adder?
A, B, seeing input and output, sum and carry.
A. Okay. Then here only I will write A comma B comma C in. Okay. These are the inputs and sum and carry. These are the outputs. Okay. Okay. Then we will select it as one bits only. Okay. If you want to go for more than one bits, then you have to select tick mark here. That means it's a now bus. Then you have to mention here bus indices. What will be the MSB? What will be the MSB? For example, if you want to choose 4-bit output, then MSB will be 3 and LSB will be 0. That means it's a 3 down to 0. That means 4-bit. Okay. Likewise, you can go for. Okay. But for the simplicity purpose, we will keep it as only single bit, 1 bit. Okay. Then next, okay, then I haven't selected A, I guess. Once again, VHDL module, full add, next, A, B, C in, sum, carry, and this sum and carry is output, right? Yes, A, B, C in, sum and carry. Next, finish. Okay. Library part. Okay. After begin, we have to actually write the code. Okay. Now tell me which type of modeling that you will go for. If you go for data flow, sorry, behavioral style of modeling, then you have to use if else statement, right? Or you can use a when else statement, anything you can use. Means you have to write the three conditions. If you have to mention if a is equal to 0, then b is equal to this, c is equal to this, then what will be the sum and carry. Else if, okay, this way also you can write the program, no problem, by using behavioral style of modeling. But that will increase the number of lines, right? That will increase the number of line, or the what we can say. See, for we have selected a, b, c in sum carries 1 bit. Okay, now for three different input conditions, okay, you have to write how many cases? 8 cases, right? Means when a and b is 0 0 0 1 1 0 1 0, and which scene is equal to 1, and same cases, same 4 cases you have to write for scene is equal to 1, right? Likewise you have to uh, work on this if you go for a behavioral style of modeling. समजताय का? जर का तुम्ही बिहेवियरल स्टाईल मॉडेल यूज केली, मीन्स इफ यू वॉन्ट टू यूज सपोज इफ एल्स स्टेटमेंट, इफ एल्स इफ स्टेटमेंट, मग पहिली केस काय येणार? इफ, okay, scene is equal to 1, else if again a and b is equal, a is equal to 1, b is equal to 0, then what you will get? Else if means you have to actually write different conditions. Okay, these four conditions for scene is equal to 1. Similarly, four conditions you have to write for scene is equal to 0. That means 8 cases you're supposed to write. Simply you can directly write the behavior of the data. बरोबर आहे. म्हणजे आपण इफ एल्स वापरतो म्हणजे काय करतो? वी आर ऍक्च्युली just describing how our design or how our model design model will uh, go, or it will behave. Okay, so you can use if else if statement also, no problem, if you go for a behavioral style of modeling. But that again will increase the number of line. Okay, and that is not a good coding sign. Okay, if you a good coder, that means you want to design or you want to write a code with minimum number of lines. That is a sign of good coding. Okay, now if we use a data flow style of modeling, there we have option of using the boolean equations, right? So we will go for that part only. Okay, now tell me what is boolean equation for sum. Sum is equal to
A XOR B XOR C.
okay, A XOR what? B XOR C. Is this right? Is this correct? Is this correct? Sum equation for the full adder. A XOR B XOR C. Is this correct?
Yes.
Okay. Now what is equation for carry? What is equation for carry?
A,
Hmm?
A and B plus B and
A
C
and B
plus
plus means in logic case what should I
or
write?
or
Or.
or,
Very right.
or
Very right. A and B
B
or B
B and
and C in, right?
yes.
Or and the last case A and C in. Okay, so this is a very simple code for full adder. Okay, now whatever the code I have written, is this correct? Okay, so for sum and carry, okay, no problem, we have written the correct equations, but whatever the code that we have written, is this correct? Let us check with the synthesis. Okay, first save it, then uh, okay, this one, design utility, then user constraint. Oh no, it is not showing an option. Why? I have made one mistake purposefully. Can anyone identify that?
Architecture type.
It is given architecture, behavioral and behavioral.
समच्या इक्वेशनला सेमिकोलॉन नाही दिला आणि कॅरीला
Exactly, very good, very good. I have missed the semicolon option here. Okay, now we will check. Okay. Okay, so now design is ready. Okay, we have synthesis this design and there is no error. Okay, error nahi hai त्याच्यात, because we have missed the semicolons. Okay, now the semicolon part is, this is our design. Okay, implement part, it will not show because to implement we must connect some hardware part and we have not connected that. Okay, now in this we can just simply check the syntax. Implementation part, it actually will not work because we must have hardware with us for that purpose, where we can implement that. So this code or whatever the files that we have uh, written here, that is okay. Now we will go for the test bench part. Okay, now for the test bench we have saved this code, no problem. Now for the test bench, what is the procedure? First we should shift to the simulation. Okay, then again new source, choose here VHDL test bench, then full add TB. Okay, this name I will give here, full add TB, that means test bench for the full adder. You can give any name. Next, finish. Now this here, this test bench file is appeared. Okay, this is the full add tb.vhd. This is the test bench code. Okay, now in this again, what we supposed to do, we have to comment this entire clock process. Okay, you can comment this entire section also, like this. Then again this line also we have to comment. Okay, Okay. Now here we have to write our test cases. That means for A, B, C in, what are the different outputs? Now we will choose A is equal to 1. Okay. Then B is equal to 0 and C in is equal to also 0. Okay. So this is the uh, so we can write after this also, no problem. Okay. So we have written this test benches, test stimulus. Hmm? Okay. A we have chosen as 1, then B 0 and C in 0. Okay. Now what output you will expect from this? What output you are expecting? First we will check behavioral syntax. Okay, yes. It is showing error. Okay, first calculate the expected outputs for A is equal to 1, B is equal to 0 and C is equal to 0. What will be the sum and carry? What is the expected output that you should calculate first? Can anyone just calculate by using the equations? What will be the sum and carry for this? For A is equal to 1, B is equal to 0, C is equal to 0. What is the problem? Can't you calculate?
1 and
The
0.
sum is 1 and carry is 0.
Hmm. Sum is 1 and carry is 0. Okay. Okay. We will try to simulate this. Show error. Okay. Now we will go back to the user code. Have we made any mistake here? No. A input, B input, sum and carry output. Right. A XOR B XOR C. It's correct. No, that's correct only. Take 3. Why it is showing error? Something wrong with the software. It's not showing an option. Okay, at least all of you are clear with the logic that we have used here. Logic, all of you clear with?
Yes, sir.
Okay, fine. We will execute. Already we have executed this. Okay, I'm doing it on another PC. Might be there may be some libraries are not there. Okay, the same program and next part, full adder, half adder, and another program that we will execute in next practical session. Okay, already we have executed this many times. Even Verilog programs also we did. I don't know what happened. Okay, anyways, we will execute this. Okay, next practical. Today we will stop here.